future legends of electronics programming, it's Prof G, and let's start writing CircuitPython programs in PyCharm. Now this is a longer lesson than usual, but it's packed with important basics on running, editing, debugging, and saving code. And these lessons will lay the groundwork for accelerated learning. So if you're new here, be sure you follow the earlier lessons in the playlist, that you've got a board with CircuitPython installed, and that you've installed PyCharm and TO to take advantage of the features shown. Let's code! So plug your Pico into your computer. You should see CircuitPy on your desktop. In our last lesson, we installed PyCharm and TO. We created a PyCharm project and configured it for CircuitPython, and let's start PyCharm. Now, PyCharm shows the last project you were working on. If you don't see this load up, you can open the project from the Welcome to PyCharm screen. And if you moved your CircuitPython school folder to another location, like your Documents folder, you can still get to your project by going to the File menu, selecting Open, then navigating to the CircuitPython school folder, finding your project, clicking it, then clicking Open. Now you can get to the files for this project by clicking on the project folder on the left side of PyCharm. This acts as a toggle to show or hide the project column. Now your board should have a file in it named code.py. That file is added to all new boards, and we also updated it during our lesson on libraries, examples, and circup. So let's open that file now. Over on the left-hand side in the project column, there's a heading for CP-project. That's the name of the project we created in the previous lesson. Now you should see two indented headings underneath this, one that also says CP-project. We're not going to touch that one, but the one that we care about is the one that says CircuitPy in all caps. If you don't see the indented headings underneath this, click the exposure triangle next to the project name so that it points down, then click the triangle next to CircuitPy so that points down, and you should see all of the files that are on the CircuitPy volume. So everything here indented under CircuitPy is on my Pico. Warning, some of these files and folders are invisible on the board. Let me show you. If I head over to the Finder and I open up the CircuitPy volume, I only see these files and folders. But over here in PyCharm, I see all these files and folders. Now on the Mac, I can toggle hidden files to show or hide by typing Shift-Command-. And now I see a bunch of items that were hidden. You really shouldn't mess with hidden items, so I'm going to toggle to hide them by typing Shift-Command- again. Now let's head back to PyCharm, and we'll open our code.py file. This is the program that runs and executes whenever we turn on our board, reset our board, and code.py will execute even when any files are saved on the board. And that could be any file, not just changes to our code.py. So let's double-click to open code.py, not underscore code.py, but code.py. That's under the CircuitPy folder that we see over here on the left. And if you completed the previous lesson on libraries, example code, and circup, this is the example code that we saved on our computer. Don't worry about understanding it. In fact, let's delete it and start from scratch. I'm going to select all the code, that's Command-A on the Mac, Control-A on Windows, and press the delete key. Before I continue, I'm going to click on the folder in the upper left, and this will toggle the project pane open and closed. And since I don't need to work with any files while I'm coding, this will give me more screen real estate to see longer lines of code, and you can always click this icon again if you need the project pane back to work with files. Let's enter a simple print statement, but I'm not going to type the word print all at once. I'm first going to type just a lowercase p, and oh, up pops code completion. This is PyCharm's way of letting me know this is a list of all of the commands that have a p in them. Now your list may or may not have print up top. That's a popular statement and one that I've used in the past, so PyCharm might eventually put your print up top too if it's not there, but you can scroll and find print. And now look what happens if I type an R after the P. These are all the commands that have both P and R in them. So code completion narrows things down. And if I type in an I, so it says PRI, this shows only the options with print in the name. And I want this first option, print. And if I press return, PyCharm completes the print statement and it adds an open and closing parenthesis, putting my cursor in between. Those parentheses are required for Python statements called functions. Those are sort of the verbs of programming. Print is a function that prints things out. And so one of the nice things about PyCharm is it'll type code for me. And by selecting something from code completion, not only can you type code faster, it also helps make sure that you don't have a spelling error or a typo, which would prevent your code from running. Now, sometimes when you're in a function, you'll see a function hint, this sort of tooltip that gives you more information about a function, like the parameters that a function can take. It doesn't really mean much to us now, and most of the time the tooltips can be ignored, they get in the way. If in our lessons I think that the information is useful, I'll point that out, but right now I don't need to see this tip, so I'm going to press escape to get rid of it. Now to get Python to print something out, we enclose it in quotes. We saw this in an earlier lesson. We also learned that the data between quotes is called a string. And watch, as I type my first double quote, PyCharm adds the closing double quote, and it puts the cursor between the two quotes. Nice. Now I'll enter something between the quotes that I want to print out. Everybody writes hello world. I think that's so hackneyed. I never write hello world. I'm going to write CircuitPython is cool! Exclamation point. And here's another thing to notice. PyCharm will color code the code that I write. For my PyCharm appearance configuration, the function print is sort of purple, the parens are black, and the string, including the double quotes, is in green. And another thing to note, why don't you click at the end of this line with your cursor next to the closing parenthesis? Now since my cursor is next to the closing parenthesis, you see PyCharm highlighted the closing paren and its matching open paren here. PyCharm will do that with other paired characters too, like quotes, square brackets, curly braces. Very handy when you're trying to match up character pairs in a complex statement. Now another great thing of the different statements being colored is if you make a mistake with your code, like if I delete the starting double quote, notice that the string is no longer green, and you'll eventually become used to the different colors that you expect to see, and if the colors look off, that'll indicate that there's probably a problem. Now PyCharm can also offer another hint that there are problems. You see the red squiggly underlines here? Those are error indicators. I like to refer to them as the red squigglies of anger. If I hover my cursor over this first wavy red line, I see a pop-up that says unresolved reference CircuitPython. Now that's not very user-friendly, but it just means that the print statement doesn't know what I want to do inside the parentheses. Things don't look normal as far as CircuitPython is concerned. So I can fix this problem by once again adding the double quote in front of CircuitPython. Pretty print shows my string in green, and my error lines go away. And if I delete the closing parenthesis, you need an open and closing parens, I see a wavy line at the end, hover my cursor over it, and it says semicolon or closing parenthesis expected. That error message is a bit more helpful. We'll add the closing parenthesis and the error goes away. So let's see the results of this printing out. Here's what we need to do. This is where we use that TO program that we installed in the last lesson. So let's go over to the left-hand column and look at these icons that line up vertically toward the bottom. Find this one for the icons that are grouped together. It's probably fourth from the top of this little grouping here. It looks like a square with a greater than symbol and a dash inside. If you hover your cursor over, the tooltip will say, this is the terminal. Click this and it opens a pane or section of PyCharm that acts just like the terminal program that we used in the earlier lesson. Yes, you can access a terminal window right from within PyCharm, and it's super handy. So there are two things that we're going to do in the terminal, and it's worth showing this on a slide. I find that this sometimes confuses new students, so hopefully this will help. First, in the PyCharm terminal, when we work with the terminal prompt, and that's going to be the percentage sign on a Mac, on a Windows it's probably the greater than symbol. When you see that command prompt, you're actually not in your CircuitPython board yet. You're executing commands on your computer. Now the kinds of commands that we're going to execute when we work with CircuitPython are things like circup. We've already seen that. That's a special program that goes and gets libraries and installs them on our board. And later on in this lesson, we'll also see that we use the command prompt to execute the CircuitPython setBoard command. That's just going to tell our PyCharm project which board we're using, and that's going to help us in code completion. And we'll also use the command prompt to figure out which port our board is connected to, and we'll use that to launch TO. There are other commands we could enter here too, and if they become important, we'll introduce them in our lessons. So what's TO? Well, it's a separate program that you launch from the terminal. Now you'll still see the output in the terminal, it'll still be text, you won't see another window open up. And TO is going to show us, through the terminal, what's going on our CircuitPy board. So when you see your command prompt for Mac or Windows, you're on your computer. When we're in TO, we're looking at our board. So we're going to use TO to see printed output from things like the print statement, to view error messages, and in a future lesson you'll use TO to access something called the REPL, which is a sort of line-by-line Python scratchpad. And as I'm about to show you, I've got a tip sheet set up with the command you need to find the port that your board is connected to and to launch TO. And every time you launch TO, you'll also get some information on how you can quit TO. That's just Control T and then type Q. So when you type Q, it's just Q, you don't hold down Control again. Let's go through this together, and then I'll show you why it's not as onerous as it might seem at first. Now to start, let me introduce you to my tip sheet. Open a browser and enter bit.ly, then CircuitPython with a capital C and a capital P, followed by -tip-sheet. Just like you see it here. I use the caps in this way so that it's more likely to show up in code completion if you don't clear your browser's URL cache. Now I'm constantly updating this doc, so you might see some commands change in here over time. I've got a few commands at the top that my students usually need right away, like help, I've run out of storage, how do I stop my code, or how do I use the REPL, but after this, most of the sections are in alphabetical order. For example, you can see over here that I've got info on using the accelerometer and the circuit playground, audio for the circuit playground, audio for the Pico, and you can scan through this if you'd like. You're going to find most of the setup code that I use in our lessons is organized here for an easy reference. And to find the TO commands, you can either scroll to the T section, but instead I'm going to pull up Find in Google Docs with Command F, and I'm going to type in TO space command, and you can see that I'm jumping to that section automatically. In Find, you can always click on these forward or backward arrows to jump around in the document as well, and here are the commands. So there are 2 steps: find your board, then launch TO. But the steps are different for Mac and Windows, so let's look at the Mac first. Here's the command to find your board. I'm going to highlight and copy this, and I give you the step-by-step. So what you'll see is a list of serial ports. You want to look for the one that has USB modem in the name, then highlight everything from the /dev all the way to the end. Then at the percentage prompt, you want to type in TO space, then paste this in and press return. That launches TO, you're set. Now for Windows, the commands are different but the same number of steps. So you can enter this command here, TO space -- list. That's all lowercase. Now you'll see a bunch of COM port listings in here, and you want to look through to see something that looks like it's your CircuitPython device. It might have the name of the board that you have, it might say CircuitPython, it might say USB device, but Windows is a little different. So for Mac, we had to copy everything on the line of output, the /dev to the end. On Windows, we just want COM and the number, so just copy that. Then at the prompt in window, you should be able to enter TO space, paste in your COM number, press return, and that'll launch TO. Follow these steps, you should be in. I'll show you what this looks like in just a bit. Windows, if for some reason these steps don't work, I've got a fallback step for you here. You can check that out on your own. And remember, Adafruit's Discord can also be super helpful if you get stuck. So let's head back to PyCharm. Since I'm on a Mac, I'm going to paste in that ls command that I copied from the tip sheet. Windows, remember your command is going to be TO space -- list. Then both of us can press return. On the Mac, look for something that says USB modem and copy from /dev all the way to the end of this line here. And on Windows, you're seeing COM number. You just want to copy your COM number, whichever one seems like it's indicating your board. Then for both Mac and Windows, you type in TO space and then paste in whatever you copied. And if everything works, you should see that TO is running. It tells you what you need to do if you want to get out of TO and get back to the command prompt. That's type Control T together and then just the letter Q alone. And it verifies that I'm connected. So always look to make sure that you're connected to TO. If for some reason it says you're not connected, you likely didn't enter the board name correctly. Cool. Now, while this might initially seem like a bit of an ordeal, hopefully now you have that URL in your browser history. So if you need to pull up the tip sheet, you can just type in bit.ly/C for CircuitPython. Hopefully the URL will pop up there. You can press return. You can find any commands you need. But also, back here in the terminal, remember the up arrow tip. First, since we're in TO, let's get out of TO. And the way that we do that is when you've clicked in the terminal, type Control T and then the letter Q. We're back at the command prompt. Now remember, at the command prompt, we can use the up arrow. Just press the up arrow on the keyboard. That shows you any previous commands that you've entered, so you can use the up arrow to find the command that you want. Here's my ls command that I used in the Mac. Press return. I can see this output, copy what I need, TO space, paste this in, and I'm back in TO. And again, you could use just this TO command up here with the name of the port afterward, but be careful, as I said, if you plug your board into different ports on your computer, you'll find the port name is different. Also, if you plug in an adapter or USB splitter, that's going to change this as well. So one more time, I'll quit TO with Control T, then Q. That gets me back to the command prompt. So this should be pretty easy to do. Just the command prompt, you'll find most of the time what you're doing is just pressing the up arrow, and if you need a fallback, you've got the tip sheet. Now we're in TO. And notice, when you don't see a percentage sign prompt, we're no longer entering commands in the terminal. Instead, we have what's called a direct serial connection with our board, our CircuitPy volume. And when TO is running like it is here, it can show us the output of our program, any errors that occurred when running our program, and it can give us access to a sort of programming scratchpad called the REPL, which we'll discuss later. So now let's head back up to the code with the print statement. And I want you to notice this. You see the tab up here that says code.py? That's the name of my file, my Python program. Well, in the last lesson, we configured PyCharm to show the unsaved changes indicator. The blue dot here is that indicator. indicator. We have unsaved changes. And when I save, I want you to notice what happens. This blue dot is going to go away. So we'll save in the Mac, that's Command S. In Windows, it's Control S. Remember, saving something to the CircuitPy volume will execute code.py. The file will save, the blue dot will go away, and we'll see some output in the terminal for the print statement that we just wrote. So I'll type Command S, do that right now, or Control S Windows, and sometimes it takes as long as 5 seconds, but ho-ho! TO shows some output in the terminal window, and if you can't see it all, you can scroll up. I get a message that the board rebooted, code.py is run, and here's the output. Here's the print statement, CircuitPython is cool, then it says code done running, nice. If you look over at your board, you should see that the LED on the board is flashing once every 5 seconds. This means that the code ran with no errors, and now it's done. In the prior lesson, we briefly mentioned that 2 red flashes mean there's an error. No error here. 1 green flash every 5 seconds means we're done running. No errors. We're looking good. Now also notice the name of our file, code.py, in the tab above. We have no blue ball in there right now because we've saved our changes. There are no unsaved changes. But let's make a change to our file. Instead of CircuitPython is cool, let's say CircuitPython is awesome. And look, as soon as I made the change, the blue dot next to code.py is back. Now let's save again. Command S on the Mac, Control S on Windows. The file saves, the blue dot goes away. The code.py file once again executes on our board. If you don't see things again, you can scroll the output in your terminal window. And here's the output. CircuitPython is awesome. Nice. Now here's something new students often do. If I click in the terminal, notice that the terminal icon is highlighted to show that I'm in here. If I press any key, as it says up here, I enter something called the REPL. That's spelled REPL. It actually stands for Read, Evaluate, Print Loop. You'll know you're in the REPL when you see 3 greater than symbols like this. Now this is an area where you can enter single lines of code and see output. We're going to talk more about this later, but I don't want to be in here. But up here it says how I can get out of this. Just type Control D, so we'll do that now. Then we can see that our code runs again. We see the updates in TO. Cool. So this code that we entered has no errors. Let's deliberately create an error so that we can see what happens. Do this with me. Head up to our string and remove the last double quote. We see the red squigglies of anger. We created an error. Now we can try to run this program again. Save, Command S on Mac, Control S on Windows. Our code's saved, but let's take a look at the output in the terminal window. This is TO reporting from our board that we've got an error in line 1. Syntax error, invalid syntax. If we look over at our Pico, we'll notice that the onboard LED flashes twice rapidly in 5-second intervals. This happens when CircuitPython code stops because of an error. And if I hover my cursor in the editor up here over the red squigglies of anger, I see the error report says missing closing quote. So this kind of error reporting is very useful in this case. Not all error reporting is great, but PyCharm's editor has much better error reporting than the online editor. Another great reason to use PyCharm. So let's fix this error. We'll add that double quote back. The red squigglies depart. Save, Command or Control S. Unsaved changes goes away. The code executes. The print result says CircuitPython is awesome, and it is. Now let's cover some more techniques in this lesson. Now you can click the terminal icon to hide the terminal, give yourself more coding room, and let's delete the print statement up here. It's not worth saving. But let's write some code to get our neopixel strip to light up in blue and stay blue. So I'm going to begin this with a comment saying show-blue-forever.py. That'll be the name that we eventually use to save this code to our CircuitPython school folder. So let's code this up. In an earlier lesson, we learned that if we're working with a neopixel strip, we need to import board, comma, neopixel, all lowercase. But hey, we see a problem in here. We're seeing the red squigglies of anger underneath neopixel. I spelled that right. This is not a problem. This line should be valid. Let's hover over the red squigglies and see what's up. No module named neopixel, all in lowercase. Now we added the neopixel library with circ-up in our last lesson, so this should be on our Pico board. Let's check this out. If I head over to the desktop, then click on my CircuitPy board, and I look inside my lib folder, I see that, yep, my lib folder has the neopixel library in here. Neopixel.mpy is correct, so that's not a problem. Well, the issue isn't my board and it isn't my code, it's PyCharm. You see, at this point, the PyCharm project does not know that this neopixel library exists. So we're going to want to import the neopixel package into our project. This has nothing to do with our board, but once we import this into PyCharm, this project will recognize the neopixel library and it will use code completion on everything that's inside that library. Super helpful. So now let me show you how we can add that neopixel library in our PyCharm project. And in the future, every time we work with a new CircuitPython library and you get an error like this, you're going to perform this identical procedure. The only thing that's going to change is the package that you select. And the procedure is almost identical to what we did when we added the CircuitPython stubs in the earlier example. So we'll head up to our PyCharm settings. In the left-hand side, expand the project. We're in CP project, and make sure that you select interpreter. Right now, it's showing that we've imported the stubs, and we also see this thing called pip. Now, the reason we're seeing the red squigglies underneath neopixel is because we don't have the neopixel package, essentially the library, listed here. And again, it's weird terminology with package because we've already seen modules and libraries. We can consider package to be pretty much the same thing. I don't think it's useful to get into the semantics of subtle differences between these different things. This column here is named package, and essentially what we're going to do is we're going to add the name of the library that we need. Although there's a bit of a quirk, the name isn't spelled exactly like the library that we're needing. We're not going to see neopixel in here. Let me show you. So to add the neopixel package, we're going to do this the same way we did with stubs. Now, I don't know if you remember that, but we clicked on this plus sign here, so just click that. That brings up this dialog box where we can search for all sorts of libraries. Why don't we enter neopixel, because that's what we want to add, and whoa, there are a lot. Now be careful, you might be tempted to select this package that's just named neopixel. After all, we're just importing something named neopixel. We're not using any of these other terms. But that's not what we want. The official CircuitPython packages all start with adafruit -CircuitPython-. So remember that. What we want to do is select this one here, adafruit -CircuitPython-neopixel. That's the official one, not the one with SPI on the end. We just want the one that ends in neopixel. Then click Install Package, then close, click OK, and ho-ho, look at that, the red squigglies go away. Nice! Now let's use this in our code. I'll add a comment that says we're going to set up a neopixel object named strip. And remember how we do that? We learned that in a prior lesson. We'll give it a name. We're going to call it strip. Set this equal to neopixel, all lowercase. That's the name of the library. And now watch what happens if I use dot notation. Ho-ho! Code completion shows everything that's available inside the neopixel library. Fantastic and super handy. We wouldn't get that with the online editor. Now I want the neopixel class. My code completion is showing this right up top. If yours isn't, you can start to type neopixel with a capital N-E-O, and you'll see you'll narrow things down. With the neopixel class, capital N, capital P selected, press return, that gets entered into your code. Now add parens, this is like going to the class factory, the neopixel factory, and we need to put in inputs in this factory to get something out. The first thing we enter is the location of the pin where our signal wire is attached, and we know that's in our board's GP16 pin, so let's start by entering board dot, and as I start to type in capital G, capital P, code completion isn't entering anything for us. It seems my PyCharm project doesn't know about the capabilities of this board. And in fact, we could type in capital G, capital P 16. I put a comma in for the next parameter, but not so fast. And now what concerns me is I see some yellow around the GP16. If I hover my cursor over the yellow, PyCharm tells me it can't find a reference to GP16. Now what this is telling us is that the PyCharm project, not our code.py file, doesn't know about GP16. This is just an issue with the PyCharm project. It's not going to crash our code, but I want code completion in PyCharm to work, and I don't want this warning to show up if it doesn't mean anything. And you're probably thinking, oh, I probably just add a board package in the way that I just added a neopixel package. But no, that is not correct. You see, board is different. The board library is customized based on the CircuitPython version installed. And remember, in our earlier lesson, we installed a specific version of CircuitPython for the type of board we're using. So since I'm using a Raspberry Pi Pico 2W, my board library was installed knowing all the pins, pin names, the built-in LED, and any other special features unique to that board. Now the way we get PyCharm to recognize and code complete for the proper board we're using is to use a command at the command prompt named CircuitPython_setBoard. This is how we do it. We open the terminal, and TO is still running. I know that because I'm not at the command prompt. To quit TO, it's Control T, then Q. We're back at the prompt. And I've got information on how to do this in our CircuitPython-tip-sheet, so let's head to the browser and take a look at that now. I'm going to Command F, Control F Windows, and search for setBoard to find that command. That's all one word, SETBOARD. And we see we've got a command, CircuitPython_setBoard, spelled like this, and then we follow this with the correctly spelled name of the board that we're using. Now I've got the names of the boards my students are using right here, but if you're using a different board and you want to look it up, you can use this command, CircuitPython_setboard-L, that's a lowercase l, not a 1. I'm going to copy that just to show you. I'll head back to the terminal, paste it into the prompt, and great googly moogly, there are hundreds of boards. But bonus, if you click into the terminal, you can search through all the terminal output. Just type Command F Mac, Control F Windows. A find box shows up in the upper right-hand corner of the terminal. I'll search for Raspberry in here, press return. There are quite a few boards with Raspberry in the name, but you can rapidly scroll through this by using the up or down arrows next to the find box. And I'll eventually find Raspberry Pi Pico 2W that my students are using. Now I could scroll down here to the prompt, enter the CircuitPython setboard command and paste this into the end, but since my students are using this board, I've already put this command in the tip sheet. I'm just going to copy this line here with a Pico 2W, paste it back in the prompt, press return, and I don't see any response, which is sort of anticlimactic, but if I'd entered the command wrong or entered an invalid board name, I'd get an error, so we're cool. But even better, look up at the code editor, home skillets. We no longer see the yellow warning around GP16. And in fact, if we delete GP16 and retype dot after board, yowza, we see all of the properties for this board. That includes all the proper pin names, any special built-in hardware. And again, this is what we get in PyCharm that we wouldn't get with the Online IDE. The sauce is awesome. So this is board.gp16, which is what I want, comma, and let's enter the rest of the parameters to create the neopixel object. That's the number of LED lights on my strip, 30 for me, and comma, and I'm going to start to type in brightness, and cool, code completion knows about that. I'll press return. The equal sign is right after brightness. I'm going to enter 0.5 to give it 50% brightness. Sweet. And now to turn on the lights in blue, we learned that in the previous lesson. We want to refer to the object strip and then say .fill, which is the fill method. It's a function, so make sure you got parens around it. But we need another set of parens for our color value. And inside those parens for blue, we want to enter 0, 0, 255. No red, no green, but full on blue. That's what 255 is. And after this, I'm going to put in a print statement that says, strip should turn blue. And now one thing I'd like to do is to keep the code running forever once the strip turns blue. Well, we can do this with an infinite loop. We know that we can say while true with a capital T for the true, colon at the end, very important to have that colon, press return. We know this indents our line, and anything indented below while true will repeat over and over again. Well, actually in here, we don't want to do anything more. We've already turned the light blue, and that's it. We just don't want to stop the program from running. We want to run forever. Now, we actually need to have at least one statement indented under while true. We don't want to do anything in here, though, but Python actually has a command that essentially means do nothing and go on to the next statement. That's pass, P-A-S-S. And I'll add a comment after this saying, this does nothing. So what happens is we start up here, we configure our strip, we turn everything blue, we're going to print out the statement, and all that stuff happens once. Then we hit while true, and everything indented in here will be repeated over and over again. The stuff indented below while true is the only stuff that repeats, but all we have in here is the pass, which does nothing. So this infinite loop is just going to keep the board powered on. In fact, you won't even see the single LED flash that indicates that your code is done running successfully, because your code is never going to be done running. It's going to run forever. And before we save, I like to turn off all the lights at the start of any program that works with NeoPixels. This way I can be sure that I have no lingering lights that are left on. So just above my strip.fill here, I'm going to add a comment saying turn strip black. And below this, I'll have another strip.fill command with two sets of parens, passing in the RGB value of 0, 0, 0. That means no light, that is effectively black. And below this, I'll add another comment saying turn strip. And I said turn strip to red. I should have said turn strip to blue. Sorry about that. I'm tired and I'm old. So let's open the terminal back up by clicking on the terminal icon, and again, never press the play button up top. The way we execute code is simply to save. Now, important pro tip, to rerun CircuitPython code from PyCharm, the board needs to detect a change. That means if you just press save again, it won't do anything unless your code has been edited. So if I want to rerun the same program without making real changes, I'll just add or delete a space at the end of a line. That tiny change counts as a change, so when I save, the board reruns the code. But we're not in TO, friends, so if we want to see our output, we've got to get into TO. I know I'm not in TO because I'm seeing the command prompt here, so I'm just going to up arrow at the terminal prompt until I find my TO launch command. For me, that's this one here. I'll press return, and I'm in TO. So see, once we go through setting things up, there are lots of slick shortcuts we can use to get where we need to. So now I'm going to click back up here in the editor. Make sure you click up inside of this, and I'm going to save by typing Command S. It's Control S in Windows. I see a print statement down below. That's TO in action. It tells me the strip should turn blue, and it does. Nice. And one more tip. Sometimes you want to interrupt your code. For example, here I've moved my print statement from outside while true, where it'll execute only once, to inside while true, where it will execute over and over again forever. And when I save, gadzooks, my friends, way too many print statements. But if you want to stop this, just click in the terminal, type CTRL C, you see where your code was interrupted, and we're done. So now I'll move my print statement back to where it was, close my terminal, and here's how to save a copy of your code.py file from your board to your CircuitPython school folder. So I'll copy the name I want to use for my first line comment, and then up in the File menu I'll select Save As. And now the directory listed here is my CircuitPy board, see in all caps, but to change this directory I click the three dot icon, navigate to the CircuitPython school folder, click Open, paste the new name over code.py, click OK, and you've saved your file. And friends, this was a long lesson, but it was packed with big learning. With these basics under our belt, we're now prepped to continue to hack.